Yeah. Hello everyone. Let me go to the next topic. Before going to the next topic, just I think only two problems are pending. Actually, I want to go to next topic, but my heart is not supporting because they are really nice problems. Maybe you can learn something, right? Please go through the next problem. Just only two programs followed by next topic we will go, right? It will take a few minutes only. Let me start. Next problem I am just writing. Main for I is equal to n, I greater than 1, I is equal to I by 2. Next one, for j is equal to 1, j less than or equal to I, j plus plus x is equal to y plus z. This is the problem. Something new, just I want to explain to you. So please take care of this. This is the problem. So if you observe clearly, right? If you observe clearly, see this problem and let me know. If you observe clearly, how many loops are there? Two loops. Are they inner loops? Yes. Inside one loop, one more is there. That is also okay. And one more thing is, I loop is how many times? Always by 2. Log n base 2. Always by 2. Log n base 2. J loop is how many times? I times. There is a dependency. Remember, even though they are inner loops, because of dependency there, you cannot multiply directly. You have to observe clearly what is going on. Accordingly, you have to take action. Right? So let me try this. Let me try. See everyone? I is equal to n. J value. So I think J loop is repeating I times. So J loop is repeating n times. I is equal to n by 2. J loop is repeating I times. So J also going to be n by 2. Next one. I is equal to n by 2 square. J loop is also going to be n by 2 square. Right? It is going on like this. It is going on. Lastly, I is equal to 1. So J loop also 1 time. So if you observe, because of they are the dependency, you cannot multiply directly. So both the things you have to into consideration. So what is the answer? I is equal to n, J loop is n. I is equal to n by 2, J loop is n by 2. I is equal to n by 4, J loop is n by 4. So like that it is going on. Lastly, I is equal to n by 2 power log n, because I maximum value log n. So 2 power log n. So J value becomes n by 2 power log n. So like that this is going on. Now I think if you observe clearly, n common. If you observe clearly, n common. Let me common n. Right? It's going to be 1 by 2 power 0, 1 by 2 power 1, 1 by 2 square, and so on. Lastly, 1 by 2 log n base 2. N common, so that is next one. N into, if you observe clearly, it is a GP series, 1 by 2 whole power 0, 1 by 2 whole power 1, 1 by 2 whole square, and so on. Lastly, 1 by 2 whole power log n. Right, next one, n common. I think it is everyone now. It is the GP series where R value less than 1. GP series R value less than 1. I think you know two formulas are there. Let me see sum of n terms in the GP. A into R value less than 1 means formula 1 minus R power n by 1 minus R. This is the formula. If R value less than 1. If R value is more than 1, ulta will happen. Because of its R value less than 1, this is the formula. N outside anyhow. A value 1 by 2 whole power 0 means 1. 1 minus R power. R is 1 by 2. Whole power. How many terms are there? Log n base 2 terms are there. By 1 minus R. 1 minus 1 by 2. 1 minus 1 by 2. Just substitute in that formula. Right? So now let me do this one. N into. right? So I think that will become 1. So 1 minus 1 by 2 whole power log n. 1 by 2 whole power log n base 2 by 1 minus 1 by 2 means 1 by 2. So this can be written as n into, this is 1 minus 0 by 1 by 2. So this can be written as order of n, right? It's actually 2 will come, 1 by 2, 2 will come up. So it will become 2n. It will become n. So time complexity of this program is order of n. Please remember this GP series how to solve. R value less than 1. This is the formula. R value more than 1. Then R power n minus 1 by R minus 1. Alright. Something nice is there that I want to say this. Right. They all will be useful. Some point of time they will come back. Please utilize it. This program time complexity order of n. It looks like n squared, but actually not n squared. Right? I value n, j n means this statement n. I value n, j will repeat n times, so every time this statement will execute. I value after n, I value not coming n minus 1. After n, I value becomes that I by 2 means n by 2. Then j also repeating n by 2. So second time loop is, first time loop is n times, second time loop is n by 2, third time loop is n by 4, fourth time loop is n by 8 and so on. Last time loop is n by 2 power log n. N common, decrease, right? So R GP series where R value less than 1, that GP series called decreasing GP series. GP series where R value less than 1, that GP series is known as decreasing GP series. Right? This is the way of calculation. I hope you got it. Right? Fine? Yeah. Let's move to next problem. This is the next problem. Let me arrange first. Let me arrange the problem. Let me arrange it. Right. So this is the problem. So what is the time complexity of this program? So let me check one time. So time complexity means loop only. So indirectly is asking this loop is how many time? Indirectly they are asking this loop is how many time? I am doing one time. Can you see this? First time loop is 1 less than n condition true. Second time if you go inside I plus plus means I value will increment by 1, I value becomes 2, s is equal to s plus I, right? S is equal to s plus I, s became 1 plus 2. Next you check 1 plus 2 is less than n or not. Next again I plus plus, s is equal to s plus I, existing 1 plus I, 1 plus 2 plus 3 is less than n. Continue like this. Let us assume that I continue like this one k time. 1 plus 2 plus 3 and so on, k minus 1. It is also less than n. No problem. Till now no problem. Right? Next one. 1 plus 2 plus 3 and so on, k minus 1 and so on, k is equal to n. Means after reaching k, they both are equal. S is increasing. After doing k time, 1 plus 2 plus 3 plus and so on, k is equal to n. So for which value of k these two will be equal, we have to find out. So I think everyone knows this can be written as sum of k natural number. What is the answer? K into k plus 1 by 2 is equal to n. For some k value both are equal. So left side if you see sum of k natural number, right? Sum of n natural number n into n plus 1 by 2, sum of k natural number k into k plus 1 by 2. Forget about small constant. This is almost equal to k square is equal to n. This is almost equal to k is equal to root n. So time complexity of this program is going to be order of n, order of root n. Big O of root n, order of root n, both are similar. It is a nice problem. So that is the reason I want to explain to you. First time, right? First time 1 less than n verified, true. Second time 1 plus 2 less than n, true. Third time 1 plus 2 plus 3 less than n, true. So if I continue k minus 1 time, 1 plus 2 plus 3 plus and so on, k minus 1 is less than n. That is also true. After doing k time, it is not less than n, it is equal to n, so fail. So for some value of k, they both will be equal, means almost like fail. Right, means k times you repeated, this is the story. So left side, sum of k natural number, k into k plus 1 by 2 is equal to n. So approximately k square is equal to n. So finally k is equal to root n. I hope you got it. This is the next problem. Time complexity purpose, many problems I said, please go through it. If you are not okay with one of the problem, nothing will happen. Revise again and again. Revise again and again. So be comfortable. In your lifetime, you will come across time complexity many times. In your lifetime, you will see time complexity many times, not one time, two times, many times. Learn now itself. Learn now itself.